Hey everyone, Professor Michael Scanlan here. So a question I get asked all the time whenever I'm doing demonstrations with like magnetism and electricity, especially electricity, is, hey, do you have one of those things, the big silver balls that makes your hair stand up? And I'm always like, really? We want to go there? I don't know if anything can make my hair stand up. We are talking about what's called a Van de Graaff generator. And yes, we do have one, okay? Why does it make your hair stand up? And why don't I like these? The first question first. And how it operates. So there's a big rubber band in here. I mean, literally that's what it is. It's a big rubber band. And when you turn it on, there's an axle in the base and one up here. And the one down here is attached to a motor. And as we've seen, converting electrical energy into mechanical energy. That's what this thing is doing down here. And it's spinning that axis. And that's going to spin the rubber band. And there's an axis up here, an axle up here. And as the rubber band rubs on them, they're different materials, it's going to generate static electricity. And the static electricity is going to get deposited onto this dome. Now this is an insulating material. So in other words, that excess electric charge, that static charge, gets trapped up here. Now, Benjamin Franklin showed us that there are two types of electric charge, and they're opposites of one another, and he called one positive and one negative. And he discovered that opposites attract one another, but like charges repel. So two positives push apart, two negatives push apart, and it's actually a very strong force. But two charges, one with positive charge, one with negative charge, would actually pull together quite strongly. So whenever I'm charging up the Van de Graaff's dome, right, I'm depositing a lot of the same type of charge up here, be it positive or negative. I'm putting a lot of it up here. They don't like each other. And so when I start off with my hand on this, now that's the key. You want to start off with your hand on it and then turn it on. Because if you turn it on and then touch it, it's going to shock you. So you put your hand on it, you turn it on. That charge, that static charge, is going to go, some of it, through you. And it's going to, some of it, go through your hair. Now, it can't get out of your hair because your hair is not connected to anything. So what's going to happen is your hair is just going to build up a lot of this same static charge. But like charges repel one another. So let's say we have a bunch of negative charges that wind up on your hair. Each strand of hair is going to have some extra negative charges that really don't like each other. So you think your hair is just going to stay down while you're filling it up with these things that don't like each other? No, they're going to push each other apart. And in the process, they're going to push your hair apart. And what that's going to do is it's going to cause your hair to stand up. What's happening is those negative charges or positive charges, whatever you happen to have, are actually pushing against one another, and that's causing your hair to spread out. And that's why your hair stands up on end. Second question, or second thing, why don't I like these? Because I always get shocked. I've gotten hit with one of these things, shocked by these things, so many times in the course of teaching. Usually it's in front of a class, so we'll see if it happens today here in video. I hope it does not. So I'm going to turn it on. These things really are fun. I'm just being silly. I'm going to turn it on and show you some of the discharge effects. So I'm going to allow it to build up some static charge, and then I'm going to let it discharge and show you that and talk about that a little bit. And then, of course, I can't do the hair standing up thing, but I'm going to be honest with you, that doesn't always work. And when it does work, it doesn't work as well as you see in a lot of the pictures. You have to have really fine hair, so no frizzy hair, no product in your hair. I mean, it's got to be perfect for it to really work well. So I'm going to show you something else that you don't always see with the Van de Graaff generators that, to me, is much cooler. All right? So let me turn this on. Let me stand up. I have here an insulating rod with a metal ball on it, and that metal ball is connected to a wire that's connected to the case of this thing to actually ground it. And so when I discharge, I'm going to discharge through this ball instead of through me. Very important to have one of these things. So let's turn it on and see how it goes. So the rubber band I hear it crackling already. The rubber band is building up charge. on that top sphere. And the ball, the little in my hand, is allowing that charge to pass through and discharge. So if I have it far out, I'll get these big shocks. If I have it close, I'll get rapid, weak shocks. I'm going to turn the lights out so we can see this in the dark. Now, do you hear it popping? What does that remind you of? Well, it should remind you of thunder. So what's happening? Okay. Air is a material. Okay, it's a medium, we would call it. And it's made up of molecules. And those molecules have electrons on their outsides, negative charges. So whenever I charge this sphere up, the more charge it has, it builds up what's called an electric field. We've talked about magnetic fields. You also have electric fields. And the more charge I add, the stronger that electric field gets. Okay. And when I have this small sphere next to it, the air in between them, the field gets so strong, it actually rips electrons off of the air molecules. It ionizes them. As we've seen before, as we've talked about before, ionized gas is a plasma, and a lot of those glow. So what am I seeing with the sparks? I'm seeing plasma, or air turn into plasma. What does it look like? It looks like miniature form of lightning, right? And when it pops, what has that done? The air has been heated extremely during that discharge. A plasma will conduct electricity, and so when it discharges, and that plasma conducts that excess charge off of here onto the little one, it heats the air around it really fast, and that causes this little shock wave. We hear that as those pops. Take this and put it on a much larger scale, say clouds and ground. This is exactly what lightning and thunder are. In fact, when I do this in class and I do these types of demonstrations, that's what I call it. I call it baby lightning and baby thunder because it's literally what it is. Okay. So pretty cool. I love just the sparks. I mean, they're awesome. They're great. I promise to show you something that, in my opinion, is better than the hair standing up, and usually, like 99% of the time, works way better than the hair standing up thing, and that is aluminum pie pans. Yeah, watch this. So, put this one on here with a little bit of tape so it stays on, because I've done it before and they just kind of slide off. I don't want that. These two, however, are not attached to anything. The bottom one's taped on just for stability. Now, when I turn this on, right, it's going to build up some excess charge on this dome, on this sphere. That charge is going to go into these tins, into these aluminum foil, I guess mini pie pans. They're all going to have the same excess charge then, which means they're going to repel one another. And what do you think is going to happen to the top two? The bottom one's taped onto the dome, so it ain't doing anything. What do you think is going to happen to the top two whenever they all get the same type of charge and that charge repels? Well, let's find out. I'm going to angle the camera up so we can see it and turn it on. Let's watch. All right, everyone, here we go. Turning it on now. Pretty cool, huh? So, those baking dishes, those pie pans, they're a conductor, they're aluminum. Whenever they got the excess charge, they repelled one another and they flew. Another thing you can do with this, I've seen, is actually get some confetti and put it on there, and the confetti will go everywhere. Same exact reason. And while hair doesn't work that well, Christmas tinsel does. In fact, that's how I used to do this a lot in my classes. I'd get some Christmas tinsel, tape it onto the top of the sphere so that it stays in place, turn it on, and the tinsel just goes all out like you see the pictures in the hair doing in those pictures. All right, everyone, thanks for watching. I hope you've enjoyed our week of demonstrations dealing with electricity and magnetism. Stay safe. I'm really looking forward to this next week as well. I'm looking forward to all of these videos. I love doing this. Thanks for your support. Thanks for watching. I'll see you later.